All right, folks, it's Bass Action, back in action here. We are continuing our discussion of matrices, and we are now going to look into some slightly more complicated techniques of working with our matrices. We're going to look at matrix multiplication, determinants, and inverses. So let's jump into some vocabulary here on the top of the page first, okay? So multiplicative identity matrix, okay? So it sounds pretty complicated when we look at this vocabulary word, but if we think about a multiplicative identity, in general, it's a number that we can multiply times another number without changing it. So just like we had our additive identity with 0, our multiplicative identity would be 1. So when we're thinking about a multiplicative identity matrix, what we want is a matrix that does not change the original matrix whenever we multiply. So what we need to understand is that in order for us to have a multiplicative identity matrix, say that 4 times fast, it needs to be a square matrix, okay? Meaning the dimensions, the row and the columns would need to be the same. So I've given an example of an identity matrix here, and this I sub 4 means the I stands for the identity matrix, and the 4 means that it's going to be a 4 by 4 matrix. What makes this an identity matrix is that when we look down this diagonal here, all of those are 1s and everything else would be a 0. So if we wanted to write an identity matrix that would be the identity 5 or a 5 by 5 identity matrix, what we would know is we would want to have a 1 in the top, and then I need 4 zeros below it, 1, 2, 3, 4. Now, continuing this pattern on down, I'm going to have a 0 here and then a 1. And then my 3 zeros, and then a 0 and a 0 and a 1 and a 0 and a 0 and a 1, 2, 3, 1, 0 and a 1, 2, 3, 4, 1. So this would be an example of a multiplicative identity matrix. So as we continue this page, we are going to actually get into matrix multiplication, which is more complicated than our matrix addition. So a very, very quick review. We did this the other day, just talking about the order of each matrix. Remember, they might also call it a dimension. Our orders are written rows by columns. So this one would be a 2 by 2. Our next one would be a 1 by 3. Our next one would be a 3 by 2 and a 2 by 3. You have to be really comfortable writing the order of the matrix in order to do matrix multiplication. Now, our next example, example 2, multiplying by a scalar, this really just means multiplying by a number. We actually did this in our previous lesson the other day. All that we need to do here is multiply whatever scalars on the outside by every element in the matrix. We saw this the other day when we wrote things that maybe looked like just a 3b, where b was some matrix that we had. So we actually already did this, but we could write this one out. We could say it's a negative 28, just multiplying that 7 times every element. 35, 63, 0. Then I'm going to write this as a 7 halves, just like that. We could technically convert that to a decimal, but better to keep it as a fraction, and then 42. Put our brackets there, and we're good to go. All right, now I'm only going to do one example of multiplying matrices here because when we get into the next page, we're going to have to apply this skill. So we're going to have one problem here, and then we'll practice it a little bit more on the next page. All right, multiplying matrices. We can only multiply 2 matrices if the number of columns in the first matrix matches the number of rows in the second matrix. Now, I'll tell you, this is not my preference of how to word it. I don't typically like to look at it in all the words. I like to focus on it in this notation like this. So when I look at it this way, what I can see that I'm looking for is these inner 2 pieces right here. Those have to match. So the columns in the first match the rows in the second. And then what happens is our resulting matrix is that. So that is what the dimensions of our resulting matrix will be. So you always have to check whether or not two matrices can actually be multiplied together before you actually jump into the problem. So let's check on this example right here. We can write our dimensions. So the first one has the dimensions of 3 by 2, and our second one has the dimensions 2 by 2. So we can check. So these inner two pieces match, so we're good to go. So these will match up, and that means our new matrix is going to be a 3 by 2 matrix. Always good to have that in your head before you get going. So are our dimensions okay? We can answer that as a yes. Now, what I have right here is just a little bit of an idea of simple breakdown of how the matrix multiplication works, but frankly, this is not going to be adequate for us. So let's just slowly work through this. What's going to happen is I need to take everything in this row and multiply it by everything in this column. So I need to do this row by this column, and this row by this column, and this row by this column. Then I'm going to repeat that process, and I'm going to do this row times this column, and this row times this column, and this row times this column. So some colors will be helpful for us as we break this down, and we're going to have to bounce back and forth between multiplication and addition. So what I like to focus on first is, let's just focus on this row. Okay, so I'm going to have this row, and this row, and this row. And I'm going to go ahead and I'm just going to write those out. So I'm going to have a 1 and a 3, and you'll notice I'm leaving a gap here for a reason, and I'm going to have a 4 and a -2, and I'm going to have a 0 and a -1. All of these values are going to help create my first column in my new matrix. So I can actually write those out again, and I'm going to spread it out. So I'm going to put them over here. I'm going to have this 1 and a 3 again, and I'm going to have my 4 and my -2 and my 0 and my -1. As you get good with this, you won't have to write all this out, but it definitely takes some practice at first. So now let's go back to what I said we were going to do. I said we were going to take this row times this column. So these values right here are going to go here and here. I'm going to put those in a different color. So I'm going to have a 1 times a 2 plus a 3 times a 6. And then I'm going to have a 4 times a 2 plus the -2 times the 6. And a 0 times a 2 plus the -1 times the 6. That's getting each of these rows times this column. Then I need to repeat that process. Each of these rows, as I've already indicated here, times this other column. So I'm going to put those in there. So now I'm going to have a 5 plus, and I'm going to put my -3 in here, and then I'll have the 5 here, put in our plus, and I'll have my -3, and I'll have my 5 and my -3. So that gives us our complete breakdown of these. And if we want, we can even go ahead and put some brackets around us to help us see. And what we can see is we said our new matrix was supposed to be a 3 by 2. So here's our 3 rows, and these are going to be the 2 columns. So our final answer, I'm going to scooch this over. Our final answer is we're going to just do all of this arithmetic. So we're going to go through and we're going to do this. We're going to do our 1 times 2, and we're going to add it to our 3 times 6. And we're just going to do all of that arithmetic there. So our final matrix is going to be my 2 plus my 18 is going to give me a 20. And my 8 plus my -12 is going to give me a -4. My 0 plus my -6 is going to give me a -6. My 5 plus my -9 is going to give me a -4. My 20 plus my +6, you got to be careful on your signs there, is going to be a 26. And lastly, I'm going to have my 0 plus my 3 is going to give me my 3. So that is my final answer for my matrix multiplication.